Welcome, everyone. You have tuned into Hawthorn University's Holistic Health and Nutrition webinar, and I want to thank you so much for joining us as we welcome Stacey Baganz for her presentation, A Deeper Insight into the Immune System, Why It Matters. You know, this is such a timely topic, and Stacey, it's so great to have you with us presenting for Hawthorn University.
Oh, thanks, Paula. I'm excited to be here.
Thank you so much. And for those of you who don't know Stacey as well as I do, let me tell you that as a Hawthorn graduate, Stacey Baganz holds a master's in holistic nutrition, and she's board certified in holistic nutrition through the National Association of Nutrition Professionals. She owns her own private practice, PC Edge, in Park City, Utah, where she helps individuals achieve their maximum potential while ensuring long-term health. Stacey combines her background in clinical and holistic nutrition with her knowledge in functional and laboratory interpretation and nutritional genetics to bring a deeper understanding of what her clients need. Living in Park City also allows Stacey the opportunity to work with athletes at all levels. She has a special interest in how nutrition supports and drastically improves performance outcomes and prevents future health problems. And when she's not working, Stacey can be found hiking or skiing in the mountains near her home or sitting on the sidelines of one of her son's baseball games. Wow, this is such a great topic, and you know, with the immune system is so important right now, and with a healthy immune system being that important, especially in the time that we're in with COVID now, we're going to delve deeper into the understanding of how chronic disease and underlying inflammation leads to impaired immunity and greater susceptibility to viral illness. And since this is going to be a comprehensive presentation, I don't want you to miss a thing. So this presentation is being recorded and it'll be available for replay on our website. I'm your host, Paula Bartholomew. And with all of that said, it's time for Stacey Baganz.
All right. Well, thank you, Paula, for having me. I'm really excited to be here connecting with the Hawthorn community and talking about the immune system, which is such a hot topic right now. Before we start, just a quick disclaimer that I'm not a doctor, and so really all the information here is presented for educational purposes only and might not be deemed standard care or practice. So today we're looking at immune system function and its role in health maintenance. We're going to talk about what happens when it goes right, and then what happens when things go wrong, and how immune system imbalances and chronic infection and inflammation can lead to higher risk of a viral infection and severity. And I hope that you gain some strategies in how to modulate and influence the immune system through nutrition. So where we're at today, I think, you know, in our current world right now, we have really two very opposing views of disease. And on one side, we have Pasteur's model of the germ theory, in which germs are the causative factor of disease, and the strategy for that would be to avoid or eradicate them in order to be healthy. And we see this today in a lot of the recommendations by the health department with the use of masks and hand sanitizer and increased disinfecting in an effort to just avoid or kill the virus. And then on the opposing side, we have disease as stemming from a weakened immune system. And so the strategy there would be to ensure that our body is optimally supported with all the nutrients that it needs, so that when we do come in contact with germs, it has the adequate arsenal of defenses to fight it. And you know, I think it's important to recognize that germs can't be entirely avoided or eradicated. And so really the best strategy would be a combination of both. And so building our immune system in a way that it can appropriately and sufficiently handle what it comes in contact with is really important. So if we look at the right concept of immunity, we would see inflammation occurring initially as a positive thing, which helps recruit molecules of the immune system into the scene of the crime or the scene of what's going on. We would be able to fight infection without severe consequences and completely eradicate it. We would have a correct balance between our innate and adaptive immune system and end up with a full resolution. So once the immune system is activated, we have wounds that heal, we get over infections, we don't have lingering pain, inflammation, or chronic problems. And then most importantly, we don't attract interest in our own tissue. So we want our immune system to react to things it should and ignore what it shouldn't, and not attack our own tissues. If we look at the world today, we're pretty stressed. I mean, we have a lot of social demands, a lot of financial worries. We're exposed to a lot of environmental toxins, and now, you know, on top of that, we have a lot of health worries and fears around what's going on with COVID. I think we're guided to make wrong food choices a lot of times. Media marketing is really powerful. There's access to cheap prepared foods, fast food culture. So we're all exposed to foods that can impair our health and cause nutrient deficiencies. And you couple that with soils being depleted of micronutrients, and you know, an increased use of antibiotics and heavy metals, pesticides, all of that, our microbiomes are impacted. And our microbiome is really influential on our immune system. And so we are seeing an increase in chronic diseases. And really a lot of these, what underlies a lot of these diseases are these inflammatory triggers. And so a lot of these stem from poor diet and lifestyle choices. They can also be influenced by our genetics to some extent, but eventually these triggers of inflammation can lead to all sorts of disease states. And so really the common, when we look at some of these common diseases that we're seeing now, the common theme here is that there's a failure of resolution. And so there's a chronic activation of the immune system. And what we're seeing in people with these disease presentations is that they have more severe outcomes when they do come in contact with a pathogen, just because their innate immune system is weakened. So the role of the immune system really is to surveil and to alert the body on what if something's gone wrong. It could be a wound, or it could be some kind of pathogen that we've come in contact with. So its job is to kill what shouldn't be there, to create a memory of what it's battled so that it can do it more effectively the next time. And then it has a role in healing our tissue and bringing about a resolution so that the immune system can quiet back down again. It's composed of two parts. So we have the innate immune system, which is really the first line of defense. And so it's physical barriers like skin and mucous membranes, chemical barriers such as acid in our stomach that would kill a pathogen that we've consumed. But when there's a breach, it's the innate immune cells that are really the first on the scene. So they are constantly on patrol, very non-specific, and can respond to about 1,000 non-human patterns. And they work in a couple different ways, primarily almost like a Pac-Man. So they use phagocytosis to engulf either pathogens or damaged tissue. And then natural killer cells can kill viruses directly. But the immune system, the innate part of the immune system, can't always work alone. And so a lot of times it will activate the adaptive immune system by using dendritic cells to take a piece of what it's engulfed and present it to the adaptive immune system, which then activates it. So the adaptive immune system is composed of T and B cells, which are really versatile and very specific. They can recognize a lot more patterns than the innate immune system, but they can only seek out one pattern at a time. They're much more slower acting, so they don't really come full force until about 7 days of an infection. And effector T cells are the ones that become activated when presented a piece of antigen, and it's their job to clone into millions and millions and go out and seek that particular antigen to kill it. They can be quieted down by regulatory T cells if need be, and they can also activate B cells to create antibodies and memory to make the immune system more effective if they come in contact with the same thing again. So I like to think of the adaptive immune system as kind of the elite special forces that provide backup and they retain memory of what they've encountered before. So if we look at it graphically, we can see how a timeline would play out with an immune reaction. So the innate immune system is initially very robust within the first few days, and it sends out cytokines, which are chemical messages to give further instructions on how to act. Sometimes this activates the adaptive immune system, and if it does, the T cells become fully cloned and in full force in about 7 to 10 days, which is why usually it takes that long to get over a viral infection. The hope is that after about 14 days, everything starts to quiet down again, and then we have a ramping up of antibodies and memory cells that will last until the next encounter. I've added this picture just as reference for you to go back to after the presentation. I really like it. I find it to be one of the most comprehensive I've found to graphically represent how the immune system interacts with itself. And so I leave it in here as reference. When we think about the innate immune system really at the most basic level, I like to start with what happens in the case of a wound where skin needs to be healed. And so in this example, I'm just assuming there's no major infection or accompanying pathogen. And we have down in purple the macrophage that just sits in the tissue and waits to become alerted that something has gone wrong. And in this case, it's tissue debris. And the macrophage is going to send out cytokines to recruit neutrophils into the tissue. And the neutrophils are going to be helped by mast cells, which will release histamine and will get swelling. And this enables the blood cell walls to become permeable so that neutrophils can come into the tissue, and their job really is to eat all the tissue debris. Sometimes they'll send out a respiratory burst of nitric oxide to kill pathogens just in case they're there. But initially it's going to be an inflammatory response, and then hopefully what happens is that there's a switch that turns this off. Inflammation quiets, and then there's signals for a repair process to start. If we look at the resolution process just in a little bit more detail, we see the macrophage sitting there on the left in the tissue, and it's sensed a break in the skin, and it's going to release inflammatory molecules, interleukin-1 and TNF-alpha, and these recruit the neutrophils into the tissue. And once they're in there, they're going to start gobbling up all the tissue debris through phagocytosis, and there's going to be a timer that starts. And so these neutrophils, they're going to die. They have a half-life of about 7 to 10 hours, and it's their job to die after they have done their job. M2 macrophages will come in. These are resolving macrophages. The goal is that they come in to create a resolution, and they will scavenge and eat these neutrophils and dispose of them. And the outcome is that the neutrophils stay intact until they're degraded by the macrophage. And so this process, all in all, will send out interleukin-10 and TGF-beta, which calm everything down. They send out stop signals. They tell the neutrophils not to come in anymore. They tell the adaptive immune system not to worry about it. They, everything's in control, and we can start tissue repair. But when things don't go this way, which in a lot of cases, we have a lot of neutrophils coming into the tissue and not enough macrophages to clear them out. So in COVID, more and more is coming out that the virus delays or kills macrophages. And so what ends up happening is that there's too many neutrophils sitting there acting in ways that we don't want them to act. And so they create a lot of nitric oxide to help kill pathogens, but this creates tissue damage and reactive oxygen species, so a lot of oxidative damage. And when they do this, they take a bunch of oxygen from the tissue, so we get a state of hypoxia in that tissue environment. Secondly, if this neutrophil waits too long after its clock has been started and no macrophage comes to engulf it, it still needs to die. And so it's going to undergo secondary necrosis where it bursts open and spills out all of the contents of what it's engulfed along with enzymes. And these enzymes were supposed to degrade what it had engulfed, but instead now it's going to cause tissue damage. And it will recruit in inflammatory macrophages, where they will then send out more inflammatory chemicals and recruit more neutrophils into the tissue and activate the adaptive immune system to take action. And so this really perpetuates a loop of more neutrophils coming in and an activation of the adaptive immune system. And T cells are really good in the case of a pathogen. They help as backup, but not so good if we're talking about tissue damage where we're presenting our own tissue to the immune system to act against ourselves. So when we think about nutrients, what nutrients we can have that are going to promote innate resolution and an effective innate response, we see that folate and B12 are really important in white blood cell formation. So here, again, it's good to know your genetics. If there's some kind of MTHFR problem going on or a B12 anemia, we're not going to be making the white blood cells that we need to make. And then we need vitamin A and zinc so that neutrophils can mature from white blood cells and go out and do their job effectively. Vitamin C is going to promote the migration of neutrophils and their ability to phagocytize pathogens. We need adequate antioxidants, so N-acetylcysteine and glutathione are really important to prevent oxidative damage to tissues. Vitamin D is going to make macrophages more effective at degrading what they've consumed. And really importantly is omega-3s in the form of EPA and DHA, because that's going to promote the resolving macrophages to come into the tissue and prevent further inflammatory states. And this day and age with the standard American diet that is primarily full of omega-6s, we can see how we're preventing resolution and creating inflammatory states by not having enough EPA and DHA in our diet. And really a deficiency in any of these nutrients is going to impair our ability to have a good innate immune response. So really nutritional status is going to lay the foundation, and knowing our biochemistry, our nutrient status, and our genetics is really going to help to identify deficiencies that we might have. And we can use functional testing as well to understand how we can therapeutically use nutrients to improve immune function. We need to ensure a nutrient-rich diet and look at digestive function. Are we assimilating the nutrients that we're intaking? we need to look at medications and alcohol and stress and sugar intake and see how these play a role in depleting nutrients from our bodies, and understand toxic burden. And are we able to detoxify with methylation? Do we have any methylation genetic problems that might impair this? So now that we've talked about the immune system really at a basic level, how is it different with a pathogen? And we've talked about how the innate immune system works with neutrophils coming in and engulfing, and natural killer cells directly killing viruses. But we also have dendritic cells that are a type of macrophage. They're going to take bits of that antigen that they have consumed and present it to a naive T cell. So we have activation of the adaptive immune system. And when they hand this off, they're going to do so with an instruction manual. And this instruction really depends on what it has engulfed. So, for example, in the case of a virus, a dendritic cell is most likely going to use interleukin 12 to promote the maturation of a Th1 cell, which is going to be best suited at killing intracellular pathogens. But if we have a food allergen or say a parasite, then the dendritic cell is going to use interleukin 4 to tell the body to make more Th2 cells, which are really effective at killing parasites and extracellular pathogens. In the case of some kind of tissue injury or self-tissue, we're going to activate Th17. And so really the job of all these effector T cells is to clone out, into an army of millions and go back to the tissue and go and attack the antigen that they've now just been programmed to kill. So once these are matured, they also themselves send out cytokines into the tissue, which, for example, a Th2 cell is not only activated by IL-4, but it also sends out IL-4. So it perpetuates kind of a tissue environment of more and more Th2 cells. And this, as we'll see in a minute, can become problematic if we have an imbalance in too many of one type of effector T cell. If we want a really robust activity against a viral threat, then our ultimate goal would be to ensure that we have a really strong communication between Th1 and the innate immune system. And we want to prevent some kind of underlying disease or inflammatory state from promoting some other kind of pathway that will take away from this one. So when we look at the Th1 immune innate pathway, we have interferon gamma and IL-12, which are the critical players in eradicating viruses, especially in an early phase of an infection where we want our antiviral response to be adequate enough to get ahead of the virus. And so we want a really strong interplay between the macrophage and the Th1 so that we can also activate natural killer cell activity and cytotoxic T cell activity. And this loop will continue, hopefully, until the pathogen is killed and resolution can ensue. If the viral burden gets ahead of the immune system's ability to suppress the infection, then the clinical course may involve much more severe symptoms. So when we have some kind of underlying physiology that's driving up either Th2 or Th17, some other kind of T cell polarization instead of Th1, then we know that that loop is going to be dampened and we're going to become more susceptible to viral threats and more prone to an influx of neutrophils that just can't reach resolution. In some of the newer studies that are coming out on COVID, this one is from the Journal of Clinical Investigation in April, and they were describing the differences in patients with moderate and severe manifestations of COVID. And what really stood out was that the people with a more severe disease process had more inflammatory cytokines and much less interferon gamma. which would promote the viral killing. So how can we best support the Th1 innate loop with nutrients? This is a kind of a really busy slide, and we have some repeat players here from my slides before. But in red, we see the nutrients that support Th1 in particular. And I'm not going to go over each one of them, but a couple do stand out, with zinc playing a really big role in thymic function, as well as helping to increase interferon gamma levels, which help promote that viral loop. So we know that vitamin C plays a really big role in all immune cells to improve function. And in a 2019 article by Nutrients, they confirmed how important vitamin C is on the ability of neutrophils to phagocytize pathogens. And they did this by showing that glucose and vitamin C are really similar in chemical structure, and so they compete for binding sites to get into the cell. And so when vitamin C uptake was impaired by having too much glucose consumption, the ability of the neutrophil to kill the virus was impaired by about 25%. So if we think about this in the context of the standard American diet, where there's really a continual consumption of sugar and refined carbohydrates, we can see how that would ultimately suppress the ability for us to fight infection. Vitamin D is also really important. There's just been so much talk about it lately in context of COVID. And what they've discovered is that our immune cells take vitamin D that has come from the liver in the form of 25-hydroxy-D, and they take it inside the cell and actually convert it to the active form, which is 125-dihydroxy-D, and they use it. And in this review by the Proceedings of Nutrition Society, they talk about how vitamin D is critical for dendritic cells to mature. And dendritic cells are the ones that will activate the adaptive immune system. So it's showing a direct correlation between vitamin D status and COVID outcomes, because there's an inability for the adaptive immune system to become activated through that Th1 loop. Vitamin D is also really important in a process known as autophagy. And there's, in this article here that's referenced, they show that autophagy can't take place unless interferon gamma and vitamin D are both present. And this is really an essential engulfing mechanism used by macrophages to destroy pathogens and to also renew our body and clear out dead cells from tissue debris. And so a deficiency of vitamin D is going to lead to an inefficiency of macrophages to work properly. Hypoxia is a state of low oxygen, and this happens a lot of times when there is an overabundance of neutrophils, because again, the neutrophils take oxygen from the tissue so that they can make this respiratory burst. And when our tissue is low in oxygen, our natural killer cells cannot mature. They mature along an oxygen gradient, and so this inhibits them from becoming fully active. And again, this is going to drive a further persistence of neutrophils into the tissue, and this cycle of chronic inflammation is going to continue. So it's really important that we know ourselves and we know our clients in terms of are we anemic? Do we have anything preventing us from carrying oxygen effectively? Do we have a circulatory problem going on? Is there some kind of chronic fibrotic respiratory problem that's perpetuating this state of hypoxia that's going to inhibit the natural killer cells from forming? And what's kind of interesting food for thought is that, you know, I think so many of us have underlying health conditions. Many go undiagnosed, and for people that now are having to wear masks for many, many hours a day, like for work situations, I think the question kind of remains, you know, are they putting themselves at greater risk by impairing this natural killer cell maturation? And that's really still to be studied and determined, but just something to think about. Berberine plays a pretty good role in helping prevent hypoxia induced neutrophil infiltration, and can be used you know, therapeutically for somebody that is in a hypoxic state. So just back to the slide that we looked at before, I didn't talk about the Th1 promoters. There's some herbs and nutrients listed on the right side that also influence Th1 polarization and can be really beneficial. Pure Encapsulations has a really great immune protocol that outlines how to use all these nutrients, and so I encourage you to go to their website and reference that. T-cell imbalances can inhibit, like I said before, having a strong Th1 innate loop, and when we look at Th2 dominance, if we remember from a previous slide, naive T cells will become Th2 when presented with interleukin-4. And this is really going to happen when there's something going on in hollow space tissue. So think mucous membranes, nasal passages, urinary tract, GI tract. One of the ways it works is to produce a lot of mucus so that it can trap and mechanically expel what shouldn't be there. This process upregulates eosinophils and basophils and B cell surveillance. So this is the type of person that's going to be typically allergenic or somebody that's prone to food allergies and intolerances. And this works to suppress Th1 because the main interleukin-4 that perpetuates this Th2 cycle suppresses the antiviral interferon gamma. And so a lot of times we see Th2 dominance in people that have unhealthy gut conditions and increased stress, because glucocorticoids can really promote IL-4. When we look at gut health kind of in a diagram, we can see how it can create a state of Th2 dominance. And if we couple poor diet, pesticides, GMOs, you know, chronic use of over-the-counter anti-inflammatory painkillers, we get inflammation in the lining of our gut. And these two loops really feed each other. But on the left side, we see this inflammation causing a loss of glutamine. And glutamine is really important for the cells of our gut. And what will happen is the tight junctions in our small intestine will become loose, and these undigested food particles and lipopolysaccharides from bad bacteria are going to get into the bloodstream where they shouldn't be, and will activate an immune system, which will eventually cause some kind of allergic reaction or make us more prone to food sensitivities. And then on the right side, we see that this causes a release of Th2 cytokines, which eventually create a loss of Th1. And that loss of Th1, we're not able to kill infections, and so dysbiosis increases, and then we feed that loop of epithelial inflammation, which keeps Th2 dominance going. And so I think Hippocrates had it right when he said that all disease tends to begin in the gut. So how do we dampen Th2? I think we have to start with removing everything that's driving gut inflammation. So be it food intolerances, medications, or Th2 promoters. I think a lot of people don't know that they're consuming something that might be promoting Th2. So a very allergic person might not benefit from having a lot of green tea or drinking a lot of berry-based smoothies, or eating a lot of soy. We need to add in nutrients that are going to heal the gut, like L-glutamine, and some that'll take down inflammation, like curcumin and resveratrol. Vitamin A and D are going to help calm the adaptive immune system by promoting regulatory T cells. And sometimes we just have to use medications and herbs to kill those gut infections to give our immune system a little leg up in killing what's there. Arabinogalactans is a really good supplement for promoting oral tolerance, and it has a double benefit of promoting that natural killer cell loop as well. We need to repopulate the gut with good bacteria, so probiotics have a huge play here, as do some herbs that will dampen the Th2 response, like perilla and N-acetylcysteine and quercetin. There's tons of research out there on probiotics and how they have immune modulating effects. There's certain strains that help to promote tolerance in the gut and reduce histamine and mast cell degradation. And I followed Pure Encapsulations and Biotics research on their two products that they have created to help people with allergies. They have a lot of research listed on their websites, but that can be of great reference. So probiotics play a really big role in helping to dampen the Th2 response and build up gut health in general. Th17 is another T cell polarization that's even more problematic. And we're seeing this really become evident now in how Th17 dominance is playing a big role in some more severe outcomes of COVID-19. Th17 is found in epithelial surveillance. So anything regarding tissue damage or infections of mucous membranes, I think skin, lungs, vascular walls, these are all going to activate a Th17 response. And it's also usually the driver behind autoimmunity. Th17 is primarily promoted by interleukin-6, and interleukin-6 comes from too many neutrophils that have become necrotic. And so you have a really inflammatory tissue damaging process. It's also activated by NF-kappa beta, and this controls the gene transcription of cytokines. And so really, if you look back on what we talked about before as the main triggers of inflammation, all of these are going to be triggering NF-kappa beta. And so we can see how the American lifestyle in particular can predispose us all for Th17 dominance. And unfortunately, NF-kappa beta is also used by viruses to help survive in the body. So it's kind of a double whammy in terms of suppressing our immune system and allowing viruses to flourish. So Th17 is really problematic because the cytokines that it releases are damaging. IL-17 is going to block IL-10, and IL-10 is the stop signal for neutrophils coming in the tissue. So we have more neutrophils coming in, causing tissue damage, and we have more dendritic cells making more interleukin-6, which just promotes a loop. IL-17 also drives up a protease called MMP9, and MMP9 is in charge of causing making holes in the tissue so that the immune cells can move through the tissue into the lymph, and it can be really damaging. IL-21 activates B cells, so we now have a higher chance of making antibodies and memory cells against our own tissue and creating an autoimmune reaction. So all in all, Th17 is creating an inflammatory environment that's self-perpetuating and non-resolving. One of the The biggest problems with Th17 dominance is they activate something called inflammasomes. And these have really been a hot topic in a lot of the COVID-19 research with regards to severity of outcomes. And they're believed to be the primary driver in poor outcomes of COVID. They've mostly been studied in macrophages, but they're found in many different cells, and they're just little protein complexes that sit inside a cell dormant. But once that cell activates, because it senses danger, they start to assemble in a circular form, in a circular pattern. And this eventually causes that cell to burst open and spill its contents out everywhere. And this starts that inflammatory process of recruiting in neutrophils and promoting Th17. And so these inflammasomes create persistent inflammation and a fibrotic state where there's lots of oxidative stress. This is also promoted by hypoxia, and again can be dampened with potassium and berberine. So lots of greens in the diet is really important for keeping inflammasomes quieted down. Neutrophils sitting in the tissue can be very problematic in another way. If we have an underlying disease process going on that promotes neutrophils sitting there, and then they are provoked by a pathogen such as COVID, they switch from engulfing things to using something called a net, which is a neutrophil extracellular trap. And these essentially are a set of antimicrobial contents that are kind of spewed out from the neutrophil in hopes to contain an infection. They're activated by really high levels of oxidative stress, and so that's why having a good intake of glutathione and acetylcysteine and vitamin C can play a big role in preventing these nets from forming at all. So if you have nets in conjunction with inflammasomes, they can cause a lot of microvascular damage that we're seeing in COVID, which then leads to the inability of oxygenating the blood. And so too many neutrophils are not a good thing and tend to predict poor outcomes for somebody that gets coronavirus. So if we just kind of look at this in a linear way, we see interleukin-1 being created by inflammasomes, which then are going to drive Th17 polarization, which encourages neutrophils to come in and spew these nets out, which then create unwanted outcomes like blood clotting and really thick mucus and, sometimes sepsis or death. So Th17 is very problematic because we are maintaining this state in which there is a failure of resolution. There's a lot of tissue damage and a possibility of self-tissue presentation, so there's going to be a likelihood of autoimmune going on. This is going to drive down Th1, and so we'll have a persistence of these underlying chronic infections that don't resolve themselves and that create more inflammation and more tissue damage. And as we just saw, too many neutrophils sitting in the tissue can lead to a release of inflammasomes and nets in certain instances of infection, which we don't want to happen. So if we look at preventing Th1 dominance or trying to sway the immune system in a different way, fasting can be a really good tool for this. And I usually encourage my clients to try to fast 14 hours overnight if they're really inflamed, maybe even more, and eat for just a more condensed period during the day, because When you fast, you allow for autophagy to happen, where cells can repair and renew themselves, tissue inflammation can get cleaned up, and a lot of times I will add in high-dose proteolytic enzymes in this process to kind of clear out some of the fibrotic tissue. We want to promote those resolving M2 macrophages to come in and tell the body it's time to quiet the immune response and heal tissue. And we do this with EPA and DHA from omega-3s. Vitamin A and D are really important in getting regulatory T cells to quiet down the immune system. We want to inhibit that inflammation driving NF-kappa beta with herbs like curcumin and resveratrol, sulforaphane in a lot of the cruciferous vegetables, potassium, bicalin is skullcap, and berberine. We want a high dose of antioxidants, so glutathione, vitamin C, so that we can prevent the possibility of NETs happening. And then sometimes we just need to figure out, is there any identify lingering infections and attack them directly with medication or herbs that would kill them. So if we look at this all graphically, we can see, immune response is not linear. Chronic inflammation is going to inhibit the efficiency at which the immune system is going to kill pathogens. It's going to diminish immune surveillance. And so, I think the big takeaway is that we want balance. We sometimes need Th2 or Th17 to come into play, but when we tip too far into an unbalanced state, then we diminish the body's ability to effectively fight viruses and other pathogens. And so I think really it's about getting our lifestyle in check and our diet choices better, our stress down. We need to identify lingering infections and try to balance the immune system in a way so that it can act when it should and not when it should be quiet. So for viral immunity, when we're talking about having a good effective response against a virus, we want an initial robust Th1 innate immune response. We want that pathogen to be fully eradicated without having the immune system overreact in a negative way. And then we want tissue healing and resolution so that we can have a quieting of the immune system and prevent too many neutrophils coming in and hanging around and having that potential to act in ways that we don't want them to act. So how do we do this? I'm going to leave you with these questions that you can ask about yourself or ask about your clients. And it's really good to know, is there an underlying infection or some kind of autoimmune process going on? What's the status of the gut? How is that contributing to imbalances? How's the diet? How is that contributing to the issue? And is the diet primarily inflammatory in nature? And what are the downstream side effects of medication that's being taken? Is it hindering by creating nutrient deficiencies or additional problems? And are there nutrient deficiencies that need to be corrected so that the body can work as it should? I've put up here some testing and resources that I have found personally really useful. If you're a practitioner or in the nutrition field and have an account with Pure Encapsulations, I really recommend their Cogence Immunology. You can get it for free through Pure Encapsulations. If you're interested in immunology, that's the place to really delve deeper. It's a great class to take. Nutrition Genome and Pure Genomics both offer genetic testing, but they also have a lot of really great webinars and educational information to teach you about how genetics impact nutrition. Optimal DX is great for learning about interpreting standard labs in a functional way and for determining functional nutrient deficiencies. The man that runs Cogent's Immunology, Samuel Yannick, he recently released a really great paper I recommend reading called Evidence Supporting a Phased Immunophysiological Approach in COVID. And it outlines recommendations for each step of the disease process and what nutrients to take when. So that's a really great paper to read. You can get it off PubMed. Vibrant Laboratories offers intracellular nutrient testing to know what your nutrient levels are, and they have a ton of immune panels. And then I like GI Map and the FIT test for food testing. There's a lot of companies out there, but those are just some that are there for your reference. And so I think after today, my hope is that we can all start to think about the immune system differently, especially in the light of things right now, that it really starts from the choices that we make with our lifestyle and with our diet, and that what's going on inside our body at the biochemical level really matters. And it matters to test that and to know what our body needs and to address it therapeutically. So I put up my personal email. I'm happy after the presentation, if you have any questions or want to be in touch, I'm always happy to respond to emails. And I've created, with all of the nutrients that I've mentioned in these slides, I've created a cheat sheet for nutritional immunomodulation. So if you go to my website and scroll to the bottom and sign up to be on the email list, I will respond back with that cheat sheet so that you can have everything that we've talked about in one place. So with that, I think I'm going to turn it back over to Paula.
All right, Stacey, I'm here.
Great.
Wow. My brain is full. Thank you very much for that. This is a strong study that you've done. I say a huge bravo to you as a Hawthorn grad for continuing your education and going deep into such an important subject of our immunity and how to support it to this level. So bravo on that and what you've brought to us today. Okay, are you ready for some questions?
Sure.
Okay. Back in the beginning when you were talking about it was the wound picture slide, there was a question that came in about mast cells pouring out histamine and asking you to explain this, what histamine is and what this reaction is.
Well, I think histamine is it's just a way to amplify the immune process. So it helps make vascular walls more permeable. And so it's really just kind of an aid to help immune cells infiltrate to where they need to be. I think of histamine as also, when you get an allergic reaction and you're about to sneeze and you've gone outside and you feel like, your nose is on fire. That's kind of the closest way to relate to how that would work, but it can also work within the body, on the vascular wall so that neutrophils can infiltrate tissue a lot easier.
Great, thank you. There was a question on on the vitamin C slide early on that it's impaired. Vitamin C and immunity is impaired when there's too much glucose consumption, and that it actually will reduce the neutrophils to be able to kill a virus. I believe that's how you framed it. But with too much glucose, I mean, are you seeing this as a consequence of the standard American diet, of the excessive sugar consumption, and how that's playing into affecting vitamin C and being able to attend to the viruses that we're exposed to?
I would say, yeah. I mean, that was the point. With so much sugar consumption and so much refined carbs in our diet, that glucose is going to compete with the ability for our immune cells to uptake vitamin C and use it in the way that they need to.
Mhm.
And so, not only would, chronic consumption of sugar or refined carbs just kind of lower our immune system in general, it would be really important in the cases of an active infection to make sure that we're not having sugar, which I think, I know me growing up, when I was sick, my mom's first reaction was to give me like a popsicle or, some type of sugar to make me feel better.
Right.
And it's really important that we avoid that so that our immune cells can work effectively.
Give you something, not feel better, but give you something she thinks you wanted.
Right.
Feel better, maybe emotionally, while you're feeling really bad when you're so sick.
Exactly.
Yeah. Wow. Yes. And don't we see it so much that when we're under stress of any kind, that we reach for things that we think comfort us. And in a situation like sugar, it's very short-lived in what that comfort is.
Absolutely.
There's another suggestion or question on the vitamin D. I think it was really a great COVID example there, but we're talking about hypoxia and masks. Are you seeing a difference in types of masks that are worn for long periods of time and how that's affecting this situation?
That's something I really just don't know how to answer. I'm intrigued by it, and I would love to see it studied more, because my inclination is to believe that when we block our ability to, have airflow from anything, it could create an increased state of hypoxia. But I don't, I don't know that there's enough studies out there and that there's enough to answer that question. And I think it also depends on, are we talking about quickly putting on a mask to go in a grocery store, or are we talking about somebody that has to sit at a
Yes.
desk for 10 hours a day wearing one without being able to take it off? So
Yeah, big difference.
yeah.
Sure. Well, this question comes to vitamin C. That years ago, Dr. Klenner would give IV vitamin C in large quantities, 20,000 to 100,000 milligrams, to stop viral infections quickly. And with vitamin C being an electron donor, have you seen anyone use this in vitamin C high dose or IV in COVID treatment?
I know that it has been recommended and by a lot of practitioners that are seeing good, alternative results. And to my knowledge, I think that, I didn't really touch on it here on direct activity of vitamin C on a virus, but I do think that in COVID, where there is a huge influx of neutrophils that don't behave nicely, and vitamin C can help prevent those neutrophils from sending out those very damaging nets. And maybe that's, one of the main roles of that in COVID is to prevent the severe outcomes of those neutrophils acting in that way.
Right. Certainly we saw vitamin C being recommended early on, and and it was eliminated off store shelves as fast as toilet paper was. Right. But coming into an IV situation is quite different, to be able to come up to this dose, to be able to bypass the gut and get directly into the bloodstream and be utilized immediately. But it also is a specific situation during COVID. It's not easy to get into IV clinics necessarily
Right.
at this point and get this kind of treatment. So, okay, question back on gut health and the use of probiotics. I saw one point on that on prebiotics. And have you been seeing in the literature the value or the suggested use of prebiotics as opposed to or definitely before probiotics?
I think prebiotics are really effective at promoting bifida populations.
Mm-hmm.
And so I kind of think of them as food for the probiotics. And so they can help establish colonies and keep them there and happy. And you can get prebiotics through food. Arachidongalactans and different fibers are also really good at doing the same thing.
Okay, thanks. So would you recommend to people that have COVID-19 to eat a whole plant-based diet rather than adding something like even chicken broth? And what would be the role of meat during an infection like this? Would it be worsening the scenario of an infection potentially?
Are you talking about during an active infection?
Yes, it seems to be with recommend to patients with COVID.
Yeah, I think in an active infection where you're really sick, and this really could be in the case of any time that you're sick,
Mm-hmm.
Chicken broth could be very helpful, but that but also fasting. I mean, there's a reason why when we're sick, we're not particularly hungry, and I think it's okay to take advantage of that because
Mm-hmm.
that promotes the body's ability to prioritize other things
Yeah.
other than digestion. And so in an acute phase, it's really not going to hurt you to have less calories and allow the body to fight what it needs to. I think a plant-based diet is great. Chicken broth would be great, and a bunch of meat might be just a little bit too heavy and too much for the digestive system. During an active.
In that situation, I'd agree. And you made a really great point about being in an acute phase. So acute phase, like a flu, like your standard flu of 3 to 5 day period of eating really lightly or liquids or even intermittent fasting or fasting could be helpful. But something like COVID that could go on for weeks, it's hard to maintain a fasting state for that long.
Absolutely. And, maybe fasting looks like 12 to 14 hours overnight, which would be more of an intermittent fast. And then I think it's really all about balance. And if you're not feeling well, then you should eat what feels good to you. But it should be nutritious and it should be void of, refined carbohydrates and sugars. So something that helps the body, not hinders it.
Certainly. And, coming into an intermittent fasting suggestion here, we could have another whole webinar just on that and addressing that with supportive immunity and bringing down inflammation, etc. But we'll come back to that. Let me see. But almost there. I'm wondering about a little case study here. I know it's on the fly here, but just to pull this all together, if we think about somebody that has an acute injury, so something's been damaged in the body, whether it's a break or just a severe bash of tissues, and And how to support this. Walk us through somebody that may be on a moderate standard American diet, eats some whole foods, but also has some levels of deficiency in terms of nutrients. How would we go about just interfacing with somebody like that?
I think it's important to reiterate that that inflammatory foods will eventually prevent full resolution. So if we're just talking about an acute injury like you broke your leg or you torn your ACL and had to have surgery, there's a point at which I talked about with the macrophages, that we want the body to switch into a state of calming the immune system and promoting tissue repair, and that really cannot be done if we have an overabundance of omega-6s from a refined diet. So I think in the whole process, it's really important to encourage, and almost at therapeutic levels of EPA and DHA. I think in an initial, I think one of the problems also with acute injuries is the chronic and long-term use of painkillers, which also will inhibit that resolution. So they're great, Advil and Tylenol for pain relief would be really important at the beginning of an acute injury to bring down that inflammation, but then when we need resolution, they need to stop, and we need to switch to things like curcumin and resveratrol and omega-3s.
Right. You see this, so much that when there's an injury, here comes the anti-inflammatories, here comes the pain medications, and there's some skill depending on how long somebody's had to take them to titrate off, to lower our dependence on them and start bringing in some other complementary nutrients as well.
Yep, absolutely.
All right, I think that brings us to a close of the questions. Thank you, everybody, for contributing to this. And so I've got some closing comments, if you'll stay for just a little bit. Yes, there's been some questions. The webinar was recorded and it'll be available on Hawthorn's website under archived webinars. Stacey Baganz will also have a link to this on her website too, as well as the slides. So please visit her site for many reasons. Sign up for her just to support her and the work that she's doing, but also it's a great site. There's so much information there. And to help us, there'll be a survey to fill out just after the webinar ends. It certainly helps me to have your feedback, and any comments that you have about this presentation will certainly be helpful. I appreciate you taking the time. I sure do. It matters that we're bringing you the best quality of presentations and the best topics for you as well. That said, our next webinar will be on August 18th. With Tracy D. Mitchell. She's the author of the Belly Burn Plan, and she's going to be presenting on female hormones, inflammation, and weight. And our next All About Alumni graduate interview is actually tomorrow, August 5th at 12 noon Pacific time, with Maria Tabone. She's a graduate of our MH&E Master's program. She's going to be presenting on her postgraduate activities and accomplishments and challenges. So I think this is a good one to tune in for sure. We've had many previous terrific grad interview presentations, so check those out in our archives. Stacey Baganz is one of them, so it's worth seeing what Stacey has done over a period of time here. Right, I think that concludes the presentation for today. I'm grateful that I work with James Bernardinelli, who engineers our webinars, and thanks for everything that you do to keep us rolling, James. Thanks again, Stacey. I really appreciate everything you put into this and the level of expertise that you brought to Hawthorn today. I want to thank everybody else for sharing this educational experience together. I want to wish you all the best of health. I sure look forward to learning more together during our Hawthorn's webinar series, are all about alumni, and certainly within Hawthorn's doors with all the courses and programs that we offer. Until I see you again, I'm going to continue to, and certainly be mindful of my immunity. as well as compassion and kindness, because what we practice grows stronger. I want a strong immune system. I want to be a healthy person. So I hope you'll join me in this too. And until then, take good care.